Is there like a little camera? Oh yeah, there it is. Okay. Okay. Everybody have paper or their notebook out? I'm assuming yes, because nobody's saying anything. All right. So today is the 5th of November. Remember the 5th of November. 25. Let me do this. Thank you. Ooh, I think that's better. Maybe. Okay. We are talking about introduction to derivatives. So in calculus, we study what happens to graphs at a specific point. But we don't just look at that point, we look at multiple points on that line. And if we were to use the instantaneous rate of change formula, like I said, that would take forever if we are doing multiple coordinates where we have to figure it out. Because in the real world, we do use calculus to study acceleration and velocity and optimization. So yes, we still use it. And if we were to measure it, it would take forever. So we are going to use something called derivatives. But before we get that, we need to show you the two differences. So the instantaneous rate of change. We talked about the instantaneous rate of change this week and last week. The instantaneous rate of change is the equation to find the rate of change at one specific x. Only one. If we wanted to find multiple, we would have to do the instantaneous rate of change multiple times, which I said will take forever. But we have something called the derivative. We should not be drawing with Sharpie on our notes. We should be copying down the notes. A derivative is the equation, right, to find the rate of change at any x value. Everybody have this top part at least? No? Yes? Maybe so? Okay. I'm going to go there. Start now. Good? Okay. So as always, we have to denote the derivative, or most things in calculus, with a notation. So to denote the derivative, the notation is as follows. F prime of x. This is not a 1. It's not a dash. It is what we call a prime. This prime shows that this is the derivative. So we say f prime of x. Again, this notation, f prime of x, is not the same, am I off screen? I am. Is not the same as f of x. They are not the same. there will be a couple instances where they are exactly the same, but we still have to denote it f prime. So for an example, we will take that problem, f of x is equal to 2x squared minus 3x. What was it? I don't remember. Plus 1? I don't remember. And f prime of x is equal to 4x minus 3. This here is our original function. This is our derivative. These two things are not equal. You have to make sure that you are using correct notation. Correct notation. Let me know when you guys are ready. Yeah, I see some of them. Thank you, Ethan. Good? Okay, can I go? Melvin, you good? Okay. So to get those things, we have derivative rules. We're going to start with two simple derivative rules, which are the basis of all of the rules that we are going to be doing. The basis of all of the rules. So we have simple derivative rules. Our first rule is called the constant rule. As a reminder, a constant is a number without a variable. Am I still on screen or no?
Yeah.
Okay. So as a reminder, a constant is a number without a variable. That rule states that if I have f of x is equal to c, where c is a constant, then the rule is very simple. F prime of x, so the derivative of this constant, is 0. Let me give you a quick example. So here's an example. So if I have f of x is equal to 12, this is a number without a variable, is a constant, then the derivative is equal to 0. The second rule we have is called the power rule. The power rule is used when we have exponents, whole number exponents. Well, we don't have to just have a full number. We have to have exponents. Every single term has to have an exponent. So we use this for polynomials, for anything with an exponent. The power rule states, if we have f of x is equal to a x to the n, where a is the coefficient. Am I going too fast? N is an exponent. Then the derivative is as follows. F prime of x. Can I move all the way up? Is anybody still writing this up here? Freddie, you got this part? Okay. The derivative says that I will take the coefficient and multiply it by the exponent. So I take the coefficient, multiply it by the exponent. I will bring down my x. And then I subtract 1 from the exponent. You do not have to memorize these rules. These rules will be given to you on any assessment, but you just have to know how to use them. So again, to find the derivative of a power rule, of a polynomial, we take the coefficient, multiply it by the exponent. Coefficient, exponent, coefficient, exponent. And then subtract 1 from the exponent. Always 1. Always 1. Never changes. If you really want to know why that is what it is, I can give you a very long, drawn-out explanation using the instantaneous rate of change formula. But we don't want that, right? When you're done writing this down, take out that other sheet. Take out the example sheet. Don't put this away because you may need to reference it for your own notes. Freddie, you want these? Darnell, you wait. Can you pass this to Freddie, please? Thank you. All right. Let's start. These are examples of polynomials because each of the terms have an exponent. I'm going to need to use, I'm just going to write the formula here. You don't have to rewrite it because you have your notes. And then remember f prime of x for a constant is equal to 0. So I'm going to start with the derivative notation because remember these are not equal. I'm going to multiply the coefficient times the exponent. What is the coefficient in here? Nope, coefficient is a number.
7.
That is an exponent. 1. If there is no exponent or number, the understood number is 1. So I'm going to have 1. This is my coefficient. 7 is my exponent. Let me label it so you can see what I'm talking about. This is A. This is N. This is A. This is N. And then I'm going to subtract 1 from the exponent. This is not connected. This is N minus 1. Any questions on that part? I'm going to keep going. Stop me if you have questions. Then I'm going to keep going. I have to do this for every term in my equation. I'm going to multiply by 2. 9 times 2. Coefficient, exponent. X to the 2 minus 1. Plus 0. Questions? Any questions on where I'm getting 0, where I'm getting the coefficients, the exponents? Okay. At this point, you're not done because we need to simplify. So we're going to simplify it as f prime of x. Is that color's good, Darna? Okay. 1 times 7 is 7. 7 minus 1 is 6. 9 times 2 is 18. And 2 minus 1 is 1. You do not have to put the plus 0. If you forget and put the plus 0 for your final answer, it's fine. Right now it's fine. We're just learning this. But further on, when we're working with the more rigorous rules, you have to make sure you do not put that 0. Additionally, this 1 is understood. So for right now, if you put the 1 as a placeholder so you know, it's okay. But further on, we are going to take off points or not give you full credit because mathematically we write it like this. Either of these two things are your final answer. Either of these two are your final answer. So if I was trying to find the instantaneous rate of change for this at x equals 2, later on you'll see all I have to do is substitute in 2. We'll be doing that a couple weeks maybe. Right? Are there any questions? Are we sure? No? You're not sure? Or Bro. Everybody has this down? No, yes, maybe so? Alright, somebody tell me how to do number 1 on the you do. I'm not going to tell you if it's correct. I'm not going to tell you if it's wrong. We need to check each other. Not like check each other, but check our work. Anybody give me the first step?
F of x, 1, parentheses 9, x, 9 minus 1.
Okay.
And minus 4, parentheses 3, x, 3 minus 1. And that's it. That's all.
That's it?
Yeah, that's as far as I go.
Okay. Can anybody continue here? Plus what? 5? Okay. What did I say is the understood exponent if there is not an exponent? So then it should be what? 5 times 1. That it? Yeah.
X.
Yeah, you're right.
X is
1 minus 1.
minus
Minus x?
10.
Minus 10?
No, wait, no. Probably.
Huh? Is that right? We don't know?
Good question,
Okay, that's fine. What is negative 10 called? I mean, like mathematically, what is negative 10 called? A constant. What is the derivative of a constant? is what?
0.
It's 0. So instead of 10, what should this be? 0.
That's so.
Okay. If Darnell gave me this and gave me a final answer like this, he would not receive full credit. Can we figure out why Darnell would not receive full credit?
Oh, I don't.
What's-
I don't know, actually.
You sure?
Yeah, I don't.
Okay. It's the prime. You have to write the prime because these two things are not the same.
What?
Remember the notation?
Yes.
So that's the notation. Are you sure? No, you don't. All right, and then we're going to simplify. 9x 8, 12x squared, 5x to the 0. At this point, I'm fine with this for now. We are fine with this for now. But further on, we need to realize that x to the 0 goes away because we literally have no x's. So it will go away. It will be f prime of x is equal to 9x to the 8th minus 12x squared plus 5. As of now, having this x to the 0 as a placeholder for you is fine. Eventually, we will take off points because that is not mathematically how we write it. Either of these two are your answers. Questions? Are we sure? So when we have, stop. When we have our quiz on Friday, we only have 35 minutes, so I'm giving you a quiz.
What's up to level 2? One?
Up to level 2, maybe 3. We'll see how we get tomorrow. So, yeah. Everybody's gonna get 100. Everybody's gonna get a level 2.
I love that.
Okay. We'll see about that. All right. Now let's look at the other ones. We are only going to do these two today, and then you'll have time to start your homework. We're going to work on these for tomorrow. All right. I'm just going to call on people. Dago, what should I do? Actually, you know what? Let me give you guys a few minutes to work on it. So we'll give you about 2 minutes to work on it. Okay? That sound good? Why is it that I only see 4 people writing? If you need help, ask us. Ethan, you get it all? You get it all? Or do you want, did you get all the notes? Ask Michi. Okay. And then you missed out when I was explaining it. Let me come and explain it to you.
Oh my god.
They're not the same equations, that's what we have to mark. So it's just F, and it looks like it's X, here we go. So here are the 2 rules that we have. We have the constant rule, that said if you have a constant, that should be without an X. What's your coefficient? Okay. If we have a number without X, it's just 0 automatically. For the power rule, the power rule says that to find the derivative, we're going to take the coefficient, that's the coefficient, and the exponent, and multiply them again. All the coefficients, the power of power. Okay. Bring on the x, and then it's the exponent minus 1. So you're going to write the exponent twice. Okay? Once is multiplication, once is exponent. Okay? So let's do this really quick. pencil. Right. So let's look at this. We're gonna do the derivative. Always first put the derivative of the symbol. Okay. Alright. So now we're gonna use that rule. We're gonna use the power rule. My coefficient is 1 because there's nothing understood. So that's 8. This is n. That's my exponent. Okay. Bring down the x. And then subtract 1 from the exponent. Okay? Here. Minus, the same here, 9 times 2. Right? Coefficient exponent. Subtract the exponent from 1. Yeah, you have to do it to every single thing in the equation. So like here, you're gonna have to do the, like 4 times, okay? This is a constant of I'm almost done. This is a constant, what is the derivative of a constant? 0, so it's plus 0. And then you just simplify this. F prime of x, 1 times 7 is 7, right? 7 minus 1 is 6. 9 times 2 is 18. 2 minus 1 is 2. Just don't make it 0. That's it. Got it? You need your notation.
Oh, was that right?
Yeah. Simplify it now. Put in your calculator. Yeah, this one go for you. Like, it looks like it's on the 9, so you won't do this. No, leave it as a fraction. It's fine.
We can have like a 1.5.
Yeah, you could also left it as a fraction. Okay. What's it, 9 over 4? Right? Oh. 3 over 2. Language. What is that? This one? I hate having them all the same thing, so I just get one. Because then, if I get any more colors, it costs extra. So one is free. Okay, good. Dago, you ready? Okay. All right, seniors, let's bring it together. All right, Dago, go ahead. G prime.
Equals 3. Parentheses 8. X. 8 minus 1. Minus 4 over 5. Parentheses 5. X minus 5 minus 1. Plus 3 over 2. Parentheses 3. X. 3 minus 1. Minus 0.
All right, stop there. Are there any questions on the steps so far? All right, this is correct. Keep going.
G prime. G equals 24. X 7. Minus 4. 4. Plus 9 over 2. X squared.
X squared. Very good. Yes. Did anybody get anything else? Are we? What's wrong? Aziz? It's not. You're just following a pattern. Just following a pattern. You're always going to be given the formula, so you don't need to memorize it. You just know how to use it. Okay? Eventually, you're going to want to do it in your head. Like, I can do 90% of these in my head. Well, yeah, because I've been practicing. But if you practice, you can do it in your head. All right. We're gonna skip the next one. Turn over. Yaha. Your homework is 1, 2, 5, and 6. 4 problems. 1, 2, 5, and 6, and we have 10 minutes. You could get most of it done, if not all of it.
1 and 2?
1, 2, 5, and 6. Same thing you're doing. Same thing. 1, 2, 5, and 6.